Hi there, in this video clip I want to go through slowly, step by step, how to calculate the relative formula mass of a compound. I spoke earlier in a video clip about the arrangements of the atoms in the periodic table, and if I took a simple example, let's say carbon 6, 12. This is the atomic mass and this is the atomic number. And here I've got some examples of the atomic mass of hydrogens 1, sulfurs 32. And I want now to show you how to calculate the relative formula mass of a compound, of a gas, is succinctly the sum of its atomic masses. Let's look at a simple one. CO2, carbon dioxide. Atomic mass of carbon is 12. There's one of those, and oxygen, there's two of those. Therefore, let's just total up the atomic masses of 1 carbon and 2 oxygen, so it's going to be 1 times 12 plus 2 times 16, which is 12 plus 32. Add them together, you get 44. So therefore, the relative formula mass of CO2 carbon dioxide is 44. Let's look at a further example, sulfuric acid, H2SO4. Hydrogens, it contains 2. Sulfur, it contains 1. Oxygen, it contains 4. So let's calculate now its relative formula mass. We've got 2 times 1 plus sulfur is 32 plus oxygen is 16 times 4. Do the math. That is equal to 98. So therefore, the formula, the relative formula mass of sulfuric acid is 98. Let's look at the relative formula mass of something else. Ca, calcium hydroxide. CaOH twice. 1 calcium. This time there's 2 oxygens and 2 hydrogens. So that would be calcium is 40, 2 oxygens plus 2 times, I'm going to put it in brackets this time, 2 times 16 plus 2 times hydrogen, which is 1. So that's going to be 40 plus 32 plus 2. So therefore the relative formula mass of calcium hydroxide is 74. Let's do one more. Let's calculate the relative formula mass of magnesium nitrate, MgNO3 twice. Everything inside that bracket is multiplied by 2. So let's go what we've been doing. Magnesium, there's 1. Nitrogen, there's 2. Oxygen, is a total of 6. So that would be magnesium, its atomic mass is 24, plus nitrogen is 2 times 14, oxygen is 6 times, I'm doing a bracket, I could put 6 times 16, 96 that is, that's 96, 28 and 24, add that together and I get 148. So that is the relative molecular formula mass of magnesium nitrate. Is a simple one, sodium chloride. Atomic mass sodium 23, chlorine 35.5, add them together, that's 58.5. The relative formula mass of sodium chloride is 58.5. You won't have to do the so complicated ones, which some of these are, but here's a more difficult one. Good old copper sulfate, CuSO4 dot 5H2O. Copper sulfate, CuSO4, its crystals also contain water of crystallization. In simple terms, it contains copper sulfate and water, and that makes the crystals. Suppose I had to calculate the relative formula mass of copper sulfate. Let's do it exactly the same. 1 copper, 1 sulfur, 4 oxygens. Now I've got 5 H2O. How many hydrogens? 5 times 2 is 10. 5 times O, 5. And I do exactly the same again. It would be 1 times copper is, well, I think I got that wrong, is 63.5, not 35.5, plus 1 sulfur plus 4 oxygens plus 10 hydrogens plus 10 oxygen. It's the principles. And why I've been through all of that is because we'll be going on to look at actual reactions, but simply, let me clear some board space, is because the law of mass action states that the mass of the reactants is equal to the mass of the products. You can't create things which don't exist. So in any chemical reaction, the balance, there's a little seesaw, the reactants is equal to the products. So if I had 50 kilos of reactants all mixed together and they completely react, I've still only got 50 kilos. I'd have 50 kilos of products. Like I said, I've laboured this point today, but you'll see why it's important in future video clips.